Hi guys. Okay, so I am doing number one from last year's free response AP Physics C exam. Okay, now remember this year's exam will be 45 minutes and it's going to be all free response questions. So they're usually 15-minute free response questions. So I'm assuming what they're going to do this year is give you three free response questions. If I hear something different than that, then I'll let you guys know, okay? So you should have already attempted this free response question and then come and watch the video. Since we only get 15 minutes a question, I'm going to attempt to make all the videos 15 minutes or less. Now, one thing that you can do is you can use your calculator, right? On this question in particular, there's a part where you got to do an integral by hand, or well, an integral. So you could do it by hand or you could use a calculator. I mean, the calculator is going to make it a lot quicker, right? And it might take me a little longer than 15 minutes because I'm explaining what I'm doing instead of just writing, right? Okay, so let's go through this. So it says in this experiment, students video analyze this to track the motion of an object falling vertically through a liquid. Yeah, some fluid. Okay, they give it a mass of 12 grams. And at the top, it starts from rest. And, and below is a graph showing it. And the dash curve represents a graph, a line of best fit. Yeah? So it looks as though we have this line that goes like this, and these data points were points actually taken from the students. Okay? So let's go to the questions and see what we got. So the first question is, does the speed of the object increase, decrease, or remain the same? Okay, well, looking at this graph, okay, so you can look at the dots and they are specifically moving in an upward trend, yeah, which means the velocity is increasing as time goes by, yeah. So this one should be a pretty easy one to get. Does the speed of the object increase, decrease, or remain the same? It increases, okay. The speed of the object increases. So you would mark that, you get a point. In a brief statement, describe the direction of the object's acceleration and how the magnitude of the acceleration changed as the object fell. Okay, so how does the acceleration change? Okay, well, what you can see here, now, one thing we can say is if this line was linear, we could say the acceleration remained the same because the velocity increases the same amount for every time interval. Yeah, that would mean a constant acceleration. In this case, you can see the velocity is not increasing the same amount with the amount of time. So it looks as though the acceleration must be decreasing as the object falls down the fluid. And remember, this is like the curve we see when you drop almost anything, because air resistance. Obviously, this isn't air resistance, um, uh, but there's like a fluid resistance that's keeping the object from accelerating as gravity would accelerate it, right? And it's going to reach a thing that we call terminal velocity, where it won't accelerate anymore at all. And it looks like it's almost reaching that terminal velocity. That terminal velocity would be when the velocity then levels out and does not increase in velocity as time goes by anymore. So right now we can see here that the acceleration is decreasing with time. Okay, so your answer here would be, in a brief statement, describe the direction of the object's acceleration. Okay, so the acceleration is downward because it's making the object move downward, and the magnitude of the acceleration as the object fell is decreasing because the velocity is not changed more. So here, let me use this. The velocity gained more velocity for every unit of time at the beginning than it was at the end. Yeah? Okay. Then, using the graph, calculate an approximate value for the magnitude of acceleration of the object at point 2. Okay, so we just need to figure out, well, we need to approximate what the acceleration is right here. Yeah? So let me grab my pen, and we are going to approximate the acceleration here. Now I want to draw a tangent line to this like dotted line. So, I mean, it's kind of hard to draw with this pen that I have here, but it looks like it would go something like this, yeah? As you can see, my tangent line, what you want is like 2 points that are easy to tell, because we're going to use y2 minus y1 because we're trying to figure out the slope over x2 minus x1. Because the slope of a velocity time graph is acceleration, right? So to approximate the value of the acceleration at point 2, we would find the slope at point 2. So I'm going to use this thing right here, and then I'm going to use this point right here and this point right here. They look like they're close to my tangent line that I drew. It doesn't need to be perfect. There's going to be a range of values they're going to accept as correct, okay? Not everyone's going to get like the exact value down to 100th of a decimal or anything. So let's just let's do this. So this is going to be my x2 y2, and this will be my x1 y1. Okay, so I need y2 first, which looks like, okay, it looks like it's about right here, which the middle would be 0.7, so this looks like it'd be about 0.75. 0.75 minus, it looks like I was using this point right here, and it looks like it'd be about 0.65. 0.65 all over x2 minus x1. So my x2 was 0.2 minus my x1 is 0.15. So I got 0.1 divided by, oh, that's not right. I meant 0.15, but I wrote 0.5. Okay, 0.2 minus 0.15 would be 0.05, right? And then we got our, let's just do that real quick. That comes out to 2. And make sure you use the correct units, so meters per second squared. And you know what? We did say earlier that the acceleration is negative, so because it's going downwards. I don't know if it asks for the magnitude of the acceleration. When I go back over here, I'll be able to tell. But if it says the magnitude of the acceleration, remember magnitude just means the number, yeah? If it asks for acceleration, then that would also include direction. So my answer is either going to be 2 or -2, depending on what they're asking for. It says calculate the magnitude of acceleration, so our answer was going to be 2. 2 meters per second squared, yeah? So my answer here is 2 meters per second squared. And remember when doing this stuff, I don't know how they're going to ask you to turn it in. It's kind of weird. But I would do all work on a separate sheet of paper and label everything well. Like make sure that you have a section, like all of this is section 1A. Yeah, don't write things on different parts of the paper. Make sure to be as organized as possible, okay? These people, they're humans that are grading this, okay? And if they can't figure out what in the world you're doing, they can't give you credit for it, okay? Okay, let's go on to the next part here. It says the students use this equation to model the speed of the falling object. Oh, man, whoops. Sorry, guys. Okay, the students use this equation to model the speed of the falling object and find the best fit coefficients to be, okay, so A is 1.18 and B is going to be 5. Use the above equation to derive an expression for the magnitude of the vertical displacement, yt, of the falling object as a function of time. Okay, so let me get the pen here. Okay, now you need to go back to some cal here and remember that the PVA section here, okay? We are currently right here in velocity. They give us velocity. We want a displacement. So that would mean that you need to go over here, which means you need to take an integral, right? To go this direction, you take a derivative, yeah? So we're going to take an integral. So we're going to do the integral of A, and I'll put the numbers in there. I usually like doing stuff with the numbers. 18, 1 minus e to the -5 t. Okay, we're doing the derivative, yeah? Okay, now they wanted it in terms of t, right? Okay, so I need to do an integral with my limits here, and remember it started at 0 times 0 because it starts at rest at time 0, and we're going to go to some time t because we want a function that is made up off off of the variable t. Now, what I can't do here, though, which is going to make this weird, is I can't do the integral of this with terms t when I'm going to be plugging in t. I want to switch this up a little bit so it just makes it more mathematically correct. Here, I'm just going to use like a theta or something just because it's easy to switch a t to a theta. I mean, you can use whatever you want. You could have put a little prime on it, like done t prime or something. Yeah. I'm just going to switch it to this. Or, you know what? Let's even just switch it to an x. People seem to be happy with x's in mathematics. Okay, and we're just going to do that. Now, guys, I could do it by hand. Yes, but I don't want to because I have a calculator that can do it, and I only have 15 minutes. So I don't want to incorrectly do an integral or spend more time than I have to when I can just type that into a calculator to do it for me. And if you're not sure how to do that, then I will show you how. Let me just write down my integral because as soon as I click off of this, it's going to delete everything I wrote down, okay? So I want to make sure that I have it written down. Okay, so I am just going to exit out of this. I'm going to open up my calculator, and you guys should have the TI Inspires just like me. Okay, let me open up a new screen here so you can see exactly what I'm doing. Okay, I'm going to go Menu, Calculus, Integral. I'm going to go from 0 to t, and I'm going to go 1.18 times 1 minus, and make sure to use this e. Don't just type e from the little keyboard at the bottom. That will not work. Negative 5, now I called it x because I am using a t in here. If I put a t here, a t here, and a t here, the calculator is not going to know what in the world I'm doing, okay? So I had to switch these variables so that it will be able to follow my expressions. Okay, so there is my function. And I would write that down as the formula for t on the answers here. So that thing that was on the last one is the answer for B1. Okay, now derive an expression for the magnitude of the net force exerted on the object as it falls through the fluid as a function of time t. Okay, so I want to do net force. Now, I know you guys know this. Force is equal to mass times acceleration, right? And it gave me the mass. Yeah, look at the previous one. It gave me the mass is 12 grams. Okay, so what I want to do here is I'm going to do force is equal to mass times acceleration. Mass is 12. But what in the world am I going to do for acceleration? Well, I have a formula for velocity. If I take the derivative of that, I will have the formula for acceleration, right? And just like before, I am not going to do this by hand. I'm going to do it in the calculator real quick, and then I'll just do 12 times whatever this is after we take the derivative, and we got our answer for a net force. Okay, so let's do that in the calculator real quick. Okay, so menu, calculus, derivative, x, or I'm sorry, t. It is going to be 1.18 times 1 minus e. Remember to use that e, negative 5t. Okay, so there is my acceleration. So we're just going to do this times 12. So 5.9 e to the negative 5t. And you know what? I'll just write it down over here. Okay, and it was 12, right? At 12 grams. Okay. So that's how you would get that answer right there. It'd be F equals 12 times 5.9 e to the negative 5t. And that is a formula for net force. Cool. Okay, the students repeat the experiment with a taller glass cylinder that is filled with the same fluid. The cylinder is tall enough so that the object reaches a constant speed. Determine the constant speed of the object. Okay, so we're still using this formula. Yeah, they just put it in a larger cylinder. Okay, well, so remember I was talking about terminal velocity? There's a point at which terminal velocity happens and the speed never changes. Okay, well, terminal velocity happens after a long period of time. Yeah, so what we could do, what I'm thinking about doing, which would just make this easy, is counting t as infinity. Yeah, if we say time is infinity, then what we can do here is we can get our formula 1.18, 1 minus e to the 5 times, or negative 5, sorry, times infinity. Like, it's supposed to be a really large number. If you use the calculator and put in, just a large number, you're going to get a close answer, okay? If I use infinity, it'll tell me the exact terminal velocity. So let's just figure out what this is. So this is going to be e to the negative infinity. Okay, well, if you don't know what that is, that's 0. Yeah, e to the negative infinity is 0. So I have 1.18 times 1 minus 0. Okay, 1 minus 0 is just 1, so it looks like our answer here is 1.18 meters per second would be our terminal velocity, or the constant speed it would reach if you gave it more time to fall. Okay, the last one. Determine the force exerted by the fluid on the object at this time. The force exerted on the fluid. Okay, like I'm thinking about what I would assume some people would want to do here is you would want to use this force formula. And I guess you could, yeah, because if you do the same thing, you could plug in infinity and you would get your answer. And I'll explain why this is the answer, because it's kind of something that should just pop into your mind. Okay, but this is 0, so 0 times anything is 0, so it's 0 newtons, yeah? Now the reason why it's 0 is because anything at a constant velocity has 0 acceleration. And if you have 0 acceleration, then that means that you have 0 force, net force acting on it, right? They had to have canceled out. If there was a force acting on it, then it would be accelerating. Okay, so that's all of this problem. I hope you did all right. And do the next problem. See ya.